Second to last example. In this example, notice that our equation is given to us in factored form. Now this is really nice for finding domain, x-intercepts, and vertical asymptotes. We don't have to factor this, it's already given to us. However, we have to be very careful with the y-intercepts and end behavior. So what I'd like you to do is pause the video and find the domain, x-intercepts, and vertical asymptotes on your own. Then come back to the video, check that those are right, and we'll do the y-intercepts and end behavior together. Check what you got with what I got. If you missed any of these, pause the video so you can see where you went wrong. Otherwise, let's do the y-intercept together. We know for the y-intercept, we're going to plug 0 in. And now we're going to simplify. So I have 0 plus 2 is 2. Square that is 4. 0 minus 3 is negative 3. Now, here's where you need to be careful. A lot of students will forget that these parentheses are multiplying parentheses. And instead of multiplying 4 times negative 3, they'll get 4 here and negative 3 here and minus them. And do 4 minus 3 and get 1. But that is incorrect. You have to remember that those parentheses mean multiply. Now I have 0 plus 1 squared is 1. And 0 minus 2 is negative 2. So that gives me negative 12 over negative 2, which is a y-intercept of 6. Okay, next I have my end behavior. This one is also very tricky because end behavior we have to look at the degree on top and the degree on bottom. However, the degree is the highest exponent in standard form. So to use factored form, we have to do something a little tricky. And this is something we did last chapter, but you may have forgotten about. We're going to take our factored form, and we're only going to look at the leading term of each factor. So I have this factor here, the leading term is x, so I get rid of the 2. I have this factor here, the leading term is x, so I get rid of the 3. I have this factor here, the leading term is x, so I get rid of the 1. And I have this factor here, the leading term is x, so I get rid of the 2. And now we look at what we have left. Now if I multiply all of these together, x squared times x is x cubed, and x squared times x is also x cubed. Now, don't simplify that because that is your degree. So we see that the degree on top is 3 and the degree on bottom is 3. So these degrees are equal, so that means I use my leading coefficients rule. And the nice thing about doing it this way is these numbers in front are your leading coefficients. So my leading coefficients are 1 over 1. So my end behavior is 1. So now I have my stars at 1. And now I can graph. Start by going through your y-intercept. Now at this y-intercept, I can't keep going this way because there's an asymptote. And I can't go down because then I would eventually have an x-intercept here. So the only option is to go up. And same thing on the other side. I can't go down because then I'd have an x-intercept. I have to go up. And I get this kind of mini parabola looking thing. Now this is an even asymptote, so we should point the same direction on both sides. Next thing I have is this x-intercept, so I'm going to come to this x-intercept. It is an even x-intercept, so I'm going to bounce off of it and then point to my star. Because I always end by pointing at my end behavior. This is an odd asymptote, so I'm going to point opposite directions. So I got that. Next thing I have is my x-intercept. This is an odd x-intercept, so I'll cross through it and point to my star. So that is our last graphing example tonight. In the last video, we're going to practice going backwards, where I'm going to give you a graph and we're going to come up with the equation for that graph together.